Hello guys, welcome to new tutorial of the Houdini. I'm Sajjad Rabi, and in this tutorial I'm gonna show you maybe the most simplest way of doing flamethrower simulation inside the Houdini. I'm going to talk about the sourcing part, which is basically the particle system, how we can control the overall shape of the flamethrower based on that particle system. We are going to do the shading and lighting with the karma inside the Solaris or USD workflow. At the end of the video, I'm gonna also show you very simple Nuke script setup just to apply different layers of the glue to make it more interesting. Although this tutorial is made for beginners, but also some of the information could be useful for more advanced users as well. So let's jump into the Houdini and begin it. Okay, first you need to open this project, Flamethrower Start. I've already put some notes here for you, so you don't need to do anything from scratch. And yeah, that's a pretty simple setup to import this gun and apply some animation on it and move the camera based on that. Like this. That's the exact same project which I've used for that video which I published in my channel a few months ago. We have environment, and these objects are coming from Megascan. I've downloaded the model of the gun from the internet. I've put the link of this model at the description below. And yeah, that's it. Let's start to do our setup. You can go inside FX Flamethrower network. We need to import that gun. If you go to the gun, that's a pretty simple setup, just loading the gun, putting it in at the center of the world, make a group. In the other hand, we have a sphere. This sphere is in front of the gun. Later, we are going to use this sphere as a source of the flamethrower. And we have velocity toward X. That's because, let me visualize that for you, because the gun is pointing toward X direction. Let me turn off environment. We don't need that for now. A new group for that, emitter, merge them, and we have two different output. This one is for render, this one is for our FX setup which we have here. I'm gonna point it to that node and out FX. We have gun. Don't forget to set transfer to into this object. Yeah. Now we need to isolate that sphere. So blast node, and you can remove the gun. We have just that lovely sphere here. Okay, now there is something. We have some kind of fast motion source, and it's pointing to different directions. As you see, it could make some trouble in pyro simulation. When you're dealing with very fast motion source, you need to increase substeps, not just for pyro but any solver in Houdini. But I also find out that sometimes we could get better result if we just decrease the speed of the source rather than increasing the substeps. We can slow it down at this step doing our simulation and then speed it up to let it turn back to the actual speed. And in this project, it's better to use this method. For doing that, we need retime node, slow down, and we need to slow it down by half or 50%. Be careful about the range. Usually I'm using very large number as a end range, and for the start frame it could be same as the start frame of your timeline. And here, yeah, it's slower, but also we have problem with velocity. That's because of this interpolation. Basically, for this one, we don't need any interpolation at all. But if you wanted to keep it on, you can also exclude velocity here to fix that problem. But let me keep going without any interpolation. Okay, that's good. In the next step, we need to apply some curl noise to this velocity. I'm going to drop down point velocity node and make sure you set this parameter to keep incoming, because we want to keep this velocity which we had from this stage. And turn on add curl noise. I'm gonna change thrill size to 0.5 to have a little more frequency. So far so good. And now we can drop down pop network. And that's interesting because you don't need to add any node here. It's pretty simple. I try to keep it very simple for beginners. We just need to do few things here. Right now the lifespan is too much, so decrease it. We can use maybe 0.4. I would like to have a little variance to the life. Now it's shorter. In attribute, I'm gonna use more inherent velocity or incoming velocity from the source, so they are going much more faster. And I would like to turn on the variance. I would like to add variance, not too much, but maybe 0.1. Okay, that's very good. There is a problem. We have too much distance between these points. They are so lonely, they are alone, we don't have any neighbors around them, and they could be problematic for pyro simulation. They could add some kind of the pointy shapes inside the pyro. To fix that, we can make a trail from these particle systems. Very simple way would be using the trail sub, the regular trail sub. See? But right now we don't have any control over this trail shape. I would like to show you a very simple way to apply the same trail, but also you will have too much control over the shape of those trails. I already made a very simple point of setup for that custom trail for you, so you don't need to make it from the scratch. But before to start play with this node, let me explain you what's the main idea behind this method. I'm going to make a copy of these particle systems with duplicate node, 50 different copies. If you want to visualize it inside the viewport, you can put some number here. We have 50 different copy of that particle system. I also need to have an attribute to keep the number of each copy. So for example, for the first one, that attribute should be 0, for the next one is 1, and of course for the last one is 49 because of this number here. This option here is doing that for you. If you turn it on, you have copy num attribute, and the value is the same as the value of each copy. But the thing is, it's only working on the primitive. But for particle system, we don't have any primitives. So basically this attribute is not useful. What we need to do is here create a new primitive per each particle systems. So if you drop down add sub, go to the particles and turn this option on, you have one primitive for your particle systems. So at this stage, we have 50 different primitives per each particle system. And now that attribute could be stored inside those primitives. If you open a spreadsheet inside the primitive attribute, you have copy num starting from 0 to 49. I'm gonna change the name to JKID. But also we need to keep those attributes inside the points, not primitive. So for doing that, you can use attribute promote and convert that primitive attribute JKID to points. Now we have JKID inside the points. I'm gonna tell you later why I need to build this JKID attribute. Okay, now let me put all of them at the same position. So we have 50 different copy of the particle system here. I'm going to drop down a point warp, and inside the point warp I want to push the points toward the velocity vector. For doing that, you can use displace along normal, connect P to position. For the direction, we need to use velocity vector, connect output to P, and now by this displacement amount we can push them toward velocity. But it's not like trail, right? That's because all of those copies which we had here are using exact same amount of displacement amount here. For example, if I use 1, all of them are 1. To make it more simpler to understand, let me draw something here for you. Let's say instead of all of the points, let's say we have just one single point. At the first, we did copy of this point 50 times, so we have 50 different points at the exact same position. In the next stage, we push that point toward velocity vector. So here is the velocity vector, and the new position is here. But because all of those 50 copies are using exact same displacement amount, all of them are going to this direction. But what if we use different displacement amount per each copy? We could have something like this. For example, a point here, 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 and here. The displacement for this one could be, for example, 0.1, for this one, for example, 0.5, and for this one, maybe 0.9. How we can have different number per each copy? For doing that, we can use that JKID which we have built here. We have different JKID per each copy. So for the first copy, it's 0. For the next one, let me change the color to make it more visible. It's for this first copy. For the next one, it's 1, 2, and for the last one is 49. The previous one is 48, for example. And we can say that JKID is between 0 to 49 if we just remap it and normalize it between 0 to 1, and then use this output to control displacement amount here. We can achieve the same result as what I draw here. So let's do that. You need to bring JKID here, JKID. Then we need to remap it by fit range. Source max needs to be same as the number of copies. So I'm going to promote it, and we have here. Now you just need to copy this parameter and link it to this parameter here. So here at the end, we have a number between 0 and 1. You just need to connect it to amount, and here we go. We have our lovely trail. You can control it by the scale parameter here, control the length, and it's working. But for now, you maybe wonder what's the difference between the regular trail and the one which we have here. The answer is here. If you connect the output of the feed to CD, you can see we have some kind of the gradient or ramp from the base toward the tip. So you can apply some specific things or specific operation like displacement to each trail and control the amount of that displacement based on the color value. We can have less displacement at the base and more displacement at the tip. Let's do that. I can use an anti-aliased noise, connect position to the output of displacement, and of course it should be 3D, add node, and add the position with the anti-aliased noise and the output. Right now we have same amount of displacement for all of the points on each trail, but if you multiply the output of the noise with that fit range, we can have less displacement at the base and more toward the end of each trail. If you want to have more control over it, you can use a ramp parameter, change it to spline or float. That's because fit range is float. Put it here, and here we go. We can control the shape very easily by this ramp parameter. For example, I would like to have more displacement at the center of each trail, or at the end, or at the base. This node here is doing exact same thing, but with a little more parameters to control. Now it's time to do the setup for pyro simulation. I would suggest you to start with pyro configure GPU ground explosion, because some of the parameters are already set to the right value. You have some pretty basic setups. You don't need to start from the scratch. By doing small changes inside the parameters of the pyro solver, you can use it for Flamethrower as well. We don't need this node and this one, but be careful about this volume rasterized node, because some of these parameters are linked to this bad guy here. So after removing these two nodes, you need to remove the expression for attribute and voxel size. Just hold Ctrl Shift and click. And also you need to connect this voxel size to voxel size of the pyro solver. So I'm going to use the copy parameter here, paste relative references. And now we can connect this to the particles, but here we also need some useful attributes for pyro simulation, like temperature or density or velocity. Actually, velocity is already here because it's coming from the pub network here. To add those attributes, you can easily use pyro source node. And here we can add density or temperature. In this case, I think temperature alone should be enough. So I'm going to add temperature attribute. And here we need to convert temperature and velocity to volume, which we have velocity and V fields here. Now let's check the pyro solver, but don't forget to change the simulation type to sparse. Now okay, it's not working, and let me check it again. Probably that's because of the source. In the sourcing tab, we don't need to emit any density from the source, because I'm going to set it to none, because we will generate density based on the flame. I mean here, emit from flame. So no need for density. Temperature is good. We don't have burn volume, so you can use temperature here. And we don't need divergence for now. For velocity, I think this method is working better. You just set the operation to add and use some small number for source scale, maybe this number. And check it again. Okay, now something is happening. Let me turn the background color to dark. First thing, I think we have too much density or smoke for this flamethrower. In the sourcing, no, sorry, inside the fields, we have emit from flame option here. You can just play with the range of the flame. I would say maybe between 0.5 and 1. In the simpler word, when the flame is less than 0.5, we don't have any smoke, and we have smoke when the flame is between 0.5 and 1. Now run the simulation again. As you see, we have much less smoke. And also you need to go to the sourcing and turn off limit source range, because we want to inject source entirely for all of the frames. Now it's better. Seems like we have too much expansion. It's more like explosion. So here, where was it? In the fields, or maybe the shape. Yeah, we have flame expansion here. Decrease it to 0.1. Now we have less expansion. I think we also need decrease p scale or particle scale of the volume. It's just too thick. I'm going to use 0.4 maybe. Check it again. Okay, it's more narrow, but we have some unwanted dots or points here. We see some separation on the source. Probably that's because of temperature field. It's not too visible in the viewport, but we have some dots or points inside the source itself, and that making that problem in the pyro solver. To fix that, you have a couple of ways, of course. You can, for example, increase the number of points inside each trail by this parameter, but also you can go to velocity blur attribute of volume rasterize and turn it on. Now we have some kind of the motion blur in the volume. If you want to have more smoother result, you can increase blur samples here, maybe 12. Now it's smoother, and set the shutter to 1. Let's check the simulation again. Okay, I think we need to have more buoyancy. So in the shape, I'm gonna increase buoyancy to 0.3. Now fire is rising up faster, and I would say we need more dissipation. It helps us to do simulation faster, because basically we gonna have a smaller container for PyroFX. I would say we also need a little more inherent velocity coming from the source to let the fire push toward this direction faster. So in the sourcing down there, we have velocity source scale. I'm gonna change it to 0.05. Okay, the result is promising, but there is a problem, and that's the lack of details or small details in the fire. And we can do that by adding extra nodes here to apply turbulence to the velocity and some gas disrupt to apply some smaller details to the fire. But before doing that, let me make the fire more visible in the viewport. Maybe we need to make it a little darker. Yeah, that's better. Now we can clearly see that we don't have any details at this part, for example. Jump inside the PyroSolver, drop down gas turbulence node, connect it to force output, and change the scale to 5. Usually when I want to apply extra noise to any pyro simulation for large scale noise or large scale details, I'm gonna use gas turbulence, and for very small details I'm gonna use gas disrupt node. But you need to be careful about gas disrupt, because if you go too much with strength you will have lots of artifacts in your pyro simulation. So we have gas disrupt for small details and gas turbulence for bigger details. Here I would suggest you to use the block-based method, because in this case you can control the size of the small details by this base block size parameter. I will keep it as 0.2 and just increase strength to 50. Let me check the simulation. Yeah, it's working. We can clearly see small details here, but that's definitely too much. If you check this part, the smoke of this part, you clearly see we lost the overall shape of the smoke, and we see too much small noise around the edge of the smoke. So one thing we can do is to use control field here. Just turn it on, and we're gonna use speed field to control the amount of the gas disrupt. And for the control range, we could say something between 3 and 6. So we are going to control gas disrupt based on the speed. It's working only if the pyro is moving too fast, if the speed is between 3 and 6. Less than 3 means we don't have any disrupt, and 6 or more than 6 means we have full power of the gas disrupt. Let's check the simulation again and see if that works. When we are dealing with the speed, you need to make sure the speed option is turned on here. This option is just computing the speed based on the velocity. So far so good. I'm still thinking the upward motion of this part is not so cool. So I have an idea. I think we can remove the velocity of the source toward y direction. In that case we will have more directional force toward this direction. For doing that we can use attribute wrangle here right before volume rasterize and remove the velocity toward y. So set it to 0, run the simulation again and see the difference. Very cool. Now we can turn the speed back to the original one. So at this point we slow down the speed by half. So here we need to do the opposite way. Again, we don't need to have an interpolation. Turn back the speed to the original speed, which was 2 times faster the current speed. I'm gonna make a flipbook. The flipbook is done, but I'm not still happy about the result. We have some step issues here. And also I think we have too much small disturbance on the smoke. Let me do a few things in the setup to make it work better. First thing, I'm gonna increase substep of the particle systems, because the points are going too fast. We need to have more substeps to have more accurate result. And also inside the PyroSolver, I'm gonna increase the block size. Maybe 2 is good. And for turbulence, I would like to change the noise type. Let's keep going with that. And to make it more high res, I'm gonna decrease the voxel size to 0.1. Now it's time to cache it out. We can drop down file cache right after slow down, or maybe it's better to say slow up node, and save it somewhere in your disk like so, and save it to the disk. The simulation is done, but I think the Flamethrower is a little too much narrow or thin. So I think it's good to use some divergence as a source as well. What divergence is doing is basically creating inward or outward forces based on each voxel. So here we have divergence. So by increasing divergence, we could have some kind of the expansion, or by decreasing divergence, we can keep Flamethrower too narrow. What I'm gonna to do is going to the pyro source, and I need to create a divergence attribute here. So I'm gonna write divergence, and scale could be something less than 1. I don't want to increase divergence too much. So we have divergence attribute, and here don't forget to add that divergence attribute to generate volume. So here we have divergence, and in the pyro solver we are going to read divergence and add this divergence with the current divergence which we have from the simulation, and change the source scale to 1. Let's do another simulation and compare the result. It's done, but I'm still not happy about it. I think we need to have more fire and smoke. So let me do one last thing. Inside the particle system, I will increase the number of points. Right now it's something, yeah, it's 5,000. I'm gonna change it to 20,000 points per each second. Now we have more points. Let me check the numbers. I'm gonna simulate it again and wait for it. Okay, it's done. And I think that's very good. That's what I wanted to see. We have good amount of the fire and smoke. And let me take a flipbook to see how is it looking, but before that we can increase the quality of volume inside the viewport. Just press D, go to the textures and increase the limit resolutions to maybe 1024, 1024 and 1024, and change this option to full HDR. Yeah, as you see, we have more details inside the viewport. Maybe 1024 is too much because viewport is going to be slow, so 512, 512, 512. Let me check that. Okay, now take a flipbook. Okay, here is the flipbook, and that's not too bad, right? Let's start to do the shading and see how is it looking in render with Karma. I would like to do the shading with Mantra. I think it's a little simpler, and after I build the shader I can go to Karma. I'm going to drop down Pyro Bake Volume, and here set the smoothness scale to 5. Let me make it a little darker like that, and for scatter, turn the scatter on. I would like to have volume scattering inside smoke. Decrease intensity scale to 100. In the fire, you need to turn on fire. Oh, that's too intense. Decrease intensity scale to something like 50. And the most important thing about the shader of the fire is this ramp and the source range. I already explained all of these details in the other tutorial which I've published 1 or 2 years ago. You can find its link at the description below. I already explained everything there with more details, so if you want to know more about the shader of the fire, you can check that video as well. Now I'm going to change the source range between 0 and 0.5 and change the shape of this ramp. I'm gonna put it to manual for now, so you could do same thing as what I'm doing, and here it's better to change the shape of the ramp to Catmull, like so. Yeah, something like that. Put it back to auto update. That's very good. Let me see how is it looking in render. So for mantra, you just need to go to render view and press render button. Oh, I don't want to render it from this camera angle, so I would have another camera. Control click on the camera and point the mantra node to that new camera. Okay, that's cam 1. Increase the pixel samples to have less noise in the render, and also we need to turn on motion blur and make sure in your FX Flamethrower in the render we are using the velocity blur. That's because we have velocity field here which could make velocity blur at the render time. So lovely. I love that. Of course, I think this drop is a little too much. You can maybe decrease the gas disrupt, but for now let's keep going with that. Now it's time to jump into the karma and doing our lighting setup with USD workflow in Houdini. Create a null here and call it, for example, out fire. Now jump to stage network for USD. First, we need to import fire inside the Solaris. For doing that, you can use sub import node, point it to that fire, FX Flamethrower, out fire. Okay. Now we need to import camera. So we have scene import cameras. And we need just to import cam 1. You should have it here. Okay. Set the display flag to this node and we have cam 1. Merge these two nodes together. Call it maybe fire. Change the background color to dark. And to render it, we need to have karma node. Just search for karma. We have karma rendering setting and this USD render here. This node is responsible for all of the settings of the karma, and this node is for when you want to render your project into the disk. Now, if you set the display flag to this guy and go to camera and set the viewport to karma, you can see the render of the smoke, and it's all black because we didn't apply the shader which we have built already inside the karma. For doing that, you can make a copy of the shader inside the pyro volume. Let me put the update to manual. As you see, all of the parameters are linked to PyroFX volume. So we need to unlock all of the parameters. For doing that, go to this parameter here and select break material references. By doing that, you have all of the parameters unlinked except this one. I don't know why, maybe it's a bug. Now you can copy this shader into Solaris, go to the stage, and we need to have material library node. Dive inside, Ctrl V, we have pyro shader. The next step, we need to apply this shader to the fire. So we have material assign. The shader, oh, it's manual. Put it back to auto and maybe set it to OpenGL for now. Here is the shader, pyro shader. We need to apply that to fire. And I don't have USD3 here. Change the workspace to Solaris. Now we can see the USD3 here, the scene graph. Select assign material, and here is the file. Just drag it to this parameter here. Now we can test it out. Go to cam1 and karma. Change the background to black or dark. Here we go. We have our fire with the correct shader. Of course, we need to apply motion blur in the karma settings. PyroFX, you need to make sure motion blur is on, but as you see, we have different parameter for velocity blur. Because fire is using velocity blur, you need to turn this option on. Set it to velocity blur. Now we have velocity blur on the fire. It's a little noisy. Let me take a snapshot. If you double click on this button, you can see that render in the separate window. It's a little noisy. To improve the noise, you can increase the primary samples to something, I don't know, maybe 32. Okay, it's done. Take another snapshot, and here are my two snaps. The first one and the second one. The second one has less noise. Now I would like to put a simple ground as an environment. For now, I'm not using this environment here. So drop down a grid, scale it up, maybe push it up a little bit close to the Flamethrower, like so. Call it ground, and we can import it in the stage. Put it back to OpenGL. And now here is one thing which I need to show you. If you want to import that grid here with regular sub import, you will lose transformation data from the object level. Let me show you. We have sub import pointed to the grid, or sorry, the ground. And if you merge it to the network, you can see it's really small at the center of the world. That's because it's not importing all of these transformation data which we have here, including this uniform scale. So if you want to have all of this information inside the Solaris, instead of sub import, you can use scene import. So here I would like to import ground and call it ground. Now we have ground with all of those transformations which we did in the object network. It's time to create a shader for the ground. Again, material library. We can use principal shader, and let's keep it gray, and we have some reflectivity. I would like to make it metallic shader. Now assign that shader to the ground object. The shader is principal shader, and drag the ground object here. Turn it back to karma. Okay. We have very nice reflection here, and we have the fire. But what about if we want to emit light from the fire? For doing that, you can drop down a geometry, render geometry settings node to the fire. Instead of playing with the global parameters, which we have, for example, in the karma render setting, we can change some specific parameters only on the fire, not all of the objects or other elements which we have here. For example, for the fire itself, I can emit light. So here, click on this button here, set or create. I want to use it as a light source. Set it to yes, and you have control over diffuse and specular for this light source. For example, if I set both of them to 0, I don't have any light here, but it could be, for example, more than 1 for both of them. You might ask yourself, we have already this light here on the ground, even without using this render setting. What that light is coming from? I would say that coming from the indirect lighting which we have here. In the limit, we have diffuse limit, so we have one bounce of light, the secondary rays I mean, and because of that we can see some kind of light here. To show this more visible, I would temporarily turn off the reflectivity of the ground, so we have just diffuse. If you go to the karma render setting and set the diffuse limit to 0, you can see, oh, still I have light. Is it coming from reflection? Yes. Let me check something inside the shader. Yeah, it's metallic, so it's still reflective material. I am going to set it to 0. Now it's not reflective, and you can see we don't have any light on the ground. If you set it back to 1, you can see the diffuse. But this diffuse is different than what we have here. Here is the light source, but here is the secondary ray. So if I set it to 0 and go to this render setting, turn it on, we can see the light is back and we have more control over this process. Let's change the shader to metallic. 1 and 1. That's it. Let me increase the image size to 1980 and wait for the render. Actually, we can do the render by this beauty here. Just render to and play. I've got an error because I forgot to set the camera to the right one. Here in the scene graph, we have cam 1. Just drag it here. That's it. And render to and play. Here is the render. Not too bad, right? Okay. If you want to render it into the disk as a sequence file, you can just define your start and the frame range and then press render to disk, and the image will be saved at this location. Now what about if we want to generate fire when the flamethrower hitting the ground, same as this project? Let's check that from the witness cam. Yeah, same as this one. So let me change few things inside the setup to make it work for this purpose, but I'm not going through to all of the steps, but just showing you the main idea of doing that. Then you can do that by yourself. First, we need to go to object network. Inside that flamethrower setup here, let me bring environment. We have environment inside this node. Put it back to auto update. Yeah, maybe fire is a little heavy. Let me turn it off. Go to FPS cam. We have environment. We need to import this environment inside this network. Object merge and bring the environment here. Okay, we have environment, and let's call it environment collision. inside pub network, just drop down the node collision, pub collision detect. Put it here and point it to that null which we have made for environment. Environment collision. We have environment here. In the behavior, first it's good to create a group for all of the points which has interaction with the environment. Let's call it environment collision, for example, and set the response to stick. So basically when the point hitting the environment, it will be stuck on the environment. Seems like the trail is a little short. We almost don't have any interaction with the environment. You can increase the lifespan a little bit, but be careful about that because it could make your pyro simulation pretty heavy. I'm gonna set the lifespan to 65. Yeah, now we have collision. But there is a problem here. When the points are hitting to the ground, they are dying very soon because of this lifespan which we have here. We need to do something to keep them more alive when they are hitting to the ground. I mean these red points. How we can do that? Of course, we can use PyroWrangle for doing that to change the lifespan only for these red points. Do you remember that group which we have built here? We can use that name here to tell this PyroWrangle to run the code only for those points, not all of the points. Now we need to change the life attribute of the particles. By default, all of them are something around 65, but for red points, I would like to change it to something else. Life equal rand ID. The output of the rand is between 0 to 1, so we can remap it to something else. The normal lifespan is 0.65. We can increase it by between 3 to maybe 5. Now let's check that. Collided points lifespan. As you can see, they are staying alive more than the other particles. And then they are starting to die based on this life here. Now we can use these red points to do another pyro simulation specifically for the ground. For example, let's say at this point we could have split to isolate environment collision points, invert selection. So we are going to use this first output for the regular Flamethrower like this. On the other hand, from the second output, we can use that for ground fire. Do we have anything? Yeah, here. So same as what we did here, we can use another pyro simulation network with pyro configure GPU ground explosion, change the settings and make it work for the ground fire. I'm not sure if we can just copy this part. Let me check that. But definitely we need to change the settings because it was made for Flamethrower with too much velocity. Here we have volume rasterized. Probably we need to increase the amount of the points to have better look of the source. One trick could be use point replicate node. Yeah, but they are above the environment, some of them, right? Yeah, we can fix that problem by raise up. Here we have ray, we have environment, and set the method to minimum distance. Here we go. Of course, we need to copy the original attribute from the particles to replicated points as well. So here, turn on copy source attributes, mostly because of the velocity. Because we need to keep the velocity for the pyro simulation. Now we have divergence and temperature attribute. We have better look of the source, and also you can apply some noise here because it's so smooth. I'm afraid we will not have very too much details in the pyro simulation. Here I'm gonna to apply the noise to the temperature attribute. It's float. You can visualize it in the viewport, of course. Set operation to multiply. Yeah, something like that. It could be animated noise. Yeah, that's it, and we can use that for our pyro simulation. Let's check few frames. For example, 63. The start frame is 63, and let's see what we have here. Yeah, when the flamethrower hitting the ground, we need to speed it up as well. Oh, why I call it slow up? It should be speed up. Weird naming. Sorry. Oh, we had it here already. What was the frame which we had interaction? Let me check it at this point. With the new retiming, we have the points at 32. So here 32. Here we go. Now if you compare this with the flamethrower, oh, that's super heavy in the viewport. Okay, these two are not matched. That's obvious because if you remember, we had changed the value of the lifespan. So we had to update the pyro simulation based on the new lifespan, which I didn't do that. And that's why these two are not matched. But if you do that on your side, you will have correct timing. When the flamethrower hitting the ground, we should have some fire rising up from the ground. Here I did simulation for more frames, and yeah, that's not too bad. Having fire on the environment when the flamethrower hitting to the ground. Okay, I think it's not so hard for you to finish this project. Just finish this part and export the new fire into Solaris network for rendering in this stage to make the same project as what I did here. And here is the very simple compositing setup which I did just to apply two different stages of the yellow to present it better. I didn't spend too much time on it. Anyway, I put the script file in the project directory for you. Feel free to play with that and improve the setup. As you see, there is nothing special in the setup, just doing some color correction, applying different type of the glow, and the first stage of the glow, the second one, and for the glow I've used soft clip to clamp the high value of the plate. And here we have this group exponential blur. Of course, it's not real exponential glow. If you go inside this group by Control Enter, you can see I put a couple of regular blur nodes with different parameters. The first step, the second one, the next one, and the next one. And as a result, we have something like this. You just need plus it with the original plate. So we have a yellow here, and doing same for this part but with different parameters. So here is the yellow, you just need to add that with the result of this stage, and here we go, the final result. Okay guys, I hope you enjoyed this tutorial, and yeah, that's it. See you in the next one.